Hello. Today, in this lecture, I will talk about polymer chemistry. My name is Dr. Abhijit Shah. I am from Chemistry Department of SRMIST of Science and Technology. I am taking BTech Chemistry course. This polymer chemistry is a part of our BTech Chemistry course. So, first thing is, what is polymer? So, you can understand that polymer means there will be uh, poly means many number of monomer unit. Means if we take ethylene molecule, for example, if we take ethylene molecule CH2, very simple molecule. So this ethylene molecule is a monomer molecule. Now if we take n number of ethylene molecule and we perform some reaction in presence of peroxide at some high temperature 120 to 200 degrees Celsius, then we will get a big molecule, a big macromolecules. This is called polyethylene. In polyethylene, you will see there will be n number of ethylene molecule linked together by a covalent bond. So this is called actually polymer. So what is polymer? Definition is polymer is a substance composed of molecule, right? Here molecule is ethylene that have long sequence of one or more bases of atom or groups of atom linked to each other by covalent bond. That is called polymer molecule. Now, since polymer is a very big molecule, we can say polymer as a macromolecule also. Polymer is a one kind of macromolecule, but all macromolecules are not polymer. Why? Because macromolecules, for example, if some molecules are very bigger in size, then we can say it is a macromolecule, macro, big. But polymer is also a big molecule, so we can say polymer is a macromolecule. But some macromolecules, but all macromolecules are not polymer. Why? Because if you see in the definition of polymer, if we see in the definition of polymer that in polymer there will be monomer molecules. That monomer unit is repeated, right? But in macromolecules, it is not necessary to have the repetition of the monomer molecule. Because of that, all macromolecules are not polymer, right? Polymer is called to macromolecules, but all macromolecules are not polymer because the repeating monomer unit may not present in all macromolecules. Okay, next. Next is the definition of monomer, definition of polymerization, definition of degree of polymerization. So the repeating unit which is present in polymer molecule is called monomer molecule. Monomer. So what is monomer? Monomer means the repeating unit which is present in our polymer molecule. That is called monomer. Now what is polymerization? The reaction. The reaction by which these monomer molecules are linked together and forming this big polymer molecule is called, that reaction is called polymerization reaction. And what is degree of polymerization? Is the number of repeating unit, means number of monomer molecules. You have seen that the first example there is an n number of ethylene molecules, so that n is called the degree of polymerization reaction. So what is the summary? Summary is in polymer molecule there is a multiple monomer molecule, and the number of monomer molecule present in polymer, that is called degree of polymerization. And what is polymerization? Polymerization is the reaction by which monomer molecules are linked together and forming this polymer. Now there is another terminology what is called functionality. What is functionality? Functionality means, say, ethylene molecule. Now ethylene molecule, you can see this is one side, there is another side, right? So if I draw, so this is one side from which reaction is possible, and this is another side from which reaction is possible. So it has functionality 2. So functionality means the functionality of monomer is defined as the number of chain links it can give rise to. Means, so from in ethylene, from this side one chain is possible, from this side ethylene molecule can react with another ethylene molecule, right? Let's say it is a site number 1, and From the another side also, ethylene molecule can react and forming another chain. So from this side and another side, both side ethylene molecule can react. So functionality will be 2, right? So functionality, what is functionality? Functionality is that number of chain that can link to this monomer molecule. That is called functionality. Now, depending on functionality, we can get different type of polymerization reaction. If the functionality is 2, there is 2 functionality is 2. So it can give you only linear polymer, right? If there is more than 2 functionality, then we will get branching or cross-link polymer, right? Branching polymer, cross-link polymer, right? So we can see here, if a monomer has functionality greater than 2, it can lead to formation of branches and network or cross-link polymer is possible, right? Okay. Next is the nomenclature of polymer. So polymer molecule can be named. There is 2 type of nomenclature. One is structure based nomenclature, another is source based nomenclature. First of all, we can say structure based nomenclature. For example, if we take this monomer molecule, that is CH3 CH2 CH2 CH double bond CH2. So what is the name of this monomer? So 1 2 3 4 5. So 1, so paint 1 in. So at one position there is a double bond, so paint 1 in. Now this is the name, IUPAC name. So if we say structure based nomenclature, structure based means, so the name of the structure is paint 1 in. So when it is forming polymer, it will form poly paint 1 in, right? Poly paint 1 in. So this is the monomer molecule, the name is paint 1 in. So paint 1 is the source. So if we write the source based nomenclature, so source based nomenclature will be poly paint 1 in. Now structure based, if it is forming polymer, so structure will be like this, right? This is the structure. So what will be the structure based nomenclature? Structure based nomenclature will be, you can see here 1 2 3. So it is, this is 1 2 3 means and propane, propyl, right? Propyl group, propane, so propyl group. So this propyl group is present at one position, right? So of ethane, so one propyl ethane, right? And 1 2 diaryl, right? There is another bond, there is another bond, so it is polymer. So 1 2, so 1 propyl ethane, 1 propyl ethane, 1 2 diaryl, and now it is polymer, so poly. So this is called structure based nomenclature. Okay, so in polymer we can have 2 type of nomenclature. One is structure based, based on the structure of the polymer. Another is source based. Source based means based on the source. So same polymer molecule can be named in 2 ways. One is structure based, where we have to find out the structure. So if this is the structure, we can say it is ethylene molecule, CH2 CH2 ethene molecule, ethane, right? So in ethane there is 1 2 diaryl and at one position propyl. So 1 propyl 1 2 di, 1 propyl ethane 1 2 diaryl in bracket, by outside will be polymer. So it is poly. And source basement, it is source is this one paint 1 in is the source. So name will be poly paint 1 in. Okay. And there is another some other examples also. So if it is isoprene starting molecule, we can get polyisoprene like that. Okay, so these are the 2 type of nomenclature is important: structure based and source based. Now classification of polymer. Classification of polymer, uh, different, we can classify the polymer different way. One is classification based on origin or source, another one based on skeletal structure, and another one based on molecular forces. Okay, so these are the different way of classification: based on origin or source, based on skeletal structure, and based on molecular force. We can classify the polymer molecules. first one, classification of polymer based on source or origin. Based on source. So polymer based on source can be classified in three types: natural polymer, synthetic polymer, and semi-synthetic. Natural polymer means the polymer which is prepared by nature, like protein molecule, starch molecule, right? They are prepared in our body, in plants, right? So these are polymer are called natural polymer. Synthetic polymer means some polymer can be synthesized uh, in a laboratory. Those are called synthetic polymer. Some polymer can be synthesized in laboratory. For example, you can see this one, adipic acid and hexamethylene diamine. If we attach, it is forming nylon 6,6. So it can be synthesized in laboratory. So this is called synthetic polymer, right? And semi-synthetic polymer means some part, for example, cellulose acetate is a molecule, right? It is natural polymer. Now, if we perform some nitration reaction, it is forming nitrocellulose. This is called synthetic polymer. So it is called semi-synthetic. This full polymer is not synthetic. Some part of the polymer is synthetic. So it is called nitrocellulose. So this nitrocellulose is the example of semi-synthetic polymer. Another example is cellulose acetate. This is called rayon. Okay, cellulose acetate is also an example of semi-synthetic polymer, right? So synthetic polymer, natural polymer, and semi-synthetic polymer. These are the three type of polymer based on um, source. Next one is linking, cross-linking. So if the polymer chain is linear, it is called linear polymer. If there is branch, it's called branch polymer. Now, if one linear chain is attached with another linear chain, this is called cross-link polymer. And network polymer means when there is much more cross-linking, it is called network polymer, right? So these are the different type of polymer based on their linkage, right? So classification of polymer based on source discuss. Now classification of polymer based on their chain number, right? If there is only single chain, linear chain, it's called linear polymer. If there are branches, it's called branch polymer. If the branches are attached with each other, called cross-link polymer. If there are more cross-linking, we call say network polymer. Now this linear polymer is also called thermoplastic polymer, and this cross-link polymer is called thermoset and elastomer. What is thermoset elastomer? I'll discuss later. Now only this thing you have to know, that what is chain, linear, what is branch, and what is cross-link and network polymer. So based on the skeletal structure, we can say polymer can be four type: linear, branch, cyclic polymer is also possible. Network and cross-link polymer is one type. Another type is cyclic polymer. Means cyclodextrin is a polymer molecule which is cyclic in structure. Cyclic in structure. So this is called cyclic polymer. Polyethylene is an example of linear polymer. Polyethyleneamine is an example of branch polymer. Polyethyleneamine. Polyethyleneamine is an example of branch polymer. Cyclodextrin is an example of cyclic polymer, and bakelite is an example of network and cross-link polymer. Okay. So this is classification based on skeletal structure. Now classification based on molecular force. So polymer, it can be also three types: thermoplastic, elastomer, and thermoset. Okay. So first we have to know what is thermoplastic. Thermoplastic is the often called plastic. Generally linear and branch polymer which become liquid upon application of the heat can be molded or remolded into any shape. Means if we have some plastic, if we heat it, it will melt. Now this melt means liquid form. If we put in some mold, it will form some another shape, right? We can change the shape of, so when it is possible, this is called thermoplastic. Now, if the polymer is linear polymer or branch polymer, then it has the property of thermoplastic property. Means it can be molded, remolded. It can be transformed into any shape. That is called thermoplastic. Okay. Okay. Next one, what is elastomer? Elastomer means elasticity when there is some elasticity in polymer. Means elastomer is a one type of cross-link polymer that can be stretched easily to high extension and rapidly recover to original dimension when the applied stress is released. Okay, cross-linking density must be less in case of elastomer. Elastomer means it is a one type of polymer where elasticity is present. Elasticity is present means if we stretch it, it will be stretched. Now, if we release the force, it will come to its original dimension. Okay, that is called elastomer. What is the example? Example is polysiloxane, polyisobutylene, butyl rubber, silicon rubber, butyl rubber. These are the example of elastomer. So elastomer, there is a cross-linking, but cross-linking density will be less. And what is thermoset? Thermoset is a rigid material. Right? They are network polymer. Cross-link polymer, when there is more cross-linking, that is called network. So thermoset is a network polymer. Okay, so in when we heat it, it will increase the degree of cross-linking, and rather becoming liquid in application of the heat, it becomes much more insoluble, means much more solid. Solid means much more solid means uh, in thermoset means if we heat this polymer, which is thermoset polymer, it will become much more insoluble, much more solidified. So we cannot change with the shape, we cannot remodule it. Okay, so like that, for example, bakelite, epoxy resin. Okay, they are thermoset. Okay, they are rigid material. Okay, so polymer can be different type based on their molecular force. Molecular force means the polymer is when there is linear and branch polymer, then it forming thermoplastic polymer. Thermoplastic polymer can be crystalline or amorphous, right? Polyethylene, polypropylene, nylon, polystyrene, these are the example of thermoplastic polymer. Now this thermoplastic polymer can be transformed into different type of shape. And what is elastomer? Elastomer example is rubber, butyl rubber, siloxane rubber, silicon rubber. Okay, elastomeric polymer property is it has elastic property. Means if we apply some force, we can extend it. If we remove the force, it will come to its original dimension. That is called rubber elastic property. And thermoset is rigid material. When there is more number of cross-linking, network polymer, and in thermoset polymer, if we heat it, it will not melt it. It will transform into more solidified because more cross-linking will happen through reaction. For example, bakelite, epoxy resin, right? They are thermoset. Okay. So thermoplastic, you can see linear, elastomeric, there will be cross-linking, but in thermoset, there will be more cross-linking. Okay. These are the example: elastomeric rubber, silicon rubber, polyurethane, thermoset, epoxy resin. Okay. These are already discussed. This part is not so much important. Okay, this is again some example of elastomer. Now there is some important thing, the molecular force. The elastomer rubber are held together by weak molecular force like hydrogen bond and van der Waals force. Fiber molecule held together by strong force. Intermolecular force between thermoplastic polymer molecules are stronger than elastomer but weaker than fiber. Thermoplastic the intermolecular force between thermoplastic polymer is stronger than elastomer. but weaker than fibers. So fibers is also one type of polymer where the intermolecular force, there is some intermolecular force. Elastomer is a one type of polymer. There is also intermolecular force. In thermoplastic, there is also intermolecular force. Now it is telling that intermolecular force between thermoplastic polymer is stronger than elastomer but weaker than fiber. In thermosetting, it's a very strong intermolecular force, right? So more strong intermolecular force in thermoplastic, thermosetting, thermoset, then fiber, then thermoplastic, and then elastomer. Okay, so these are the four different type of polymer. So elastomer, very weak intermolecular force, then thermoplastic, okay, then fiber, and then thermosets. Example of thermoplastic is given here, nylon 66. Sorry, example of fiber is given here, nylon 6 fiber. Example of thermoplastic, PVC, polyethylene, polyvinyl chloride, huh? Then polystyrene, thermoplastic. Elastomer is neoprene or rubber, and thermosetting, bakelite and resin. Okay, this intermolecular force part is important. Next, already discussed thermoplastic and thermosetting. Thermosetting means strong intermolecular force, and thermoplastic weak intermolecular force. And thermosets polymer remains hard when heated. Okay, and but thermoplastic becomes softened, becomes liquid. Okay, when heated. Okay, so this is the difference. Now, the, okay. Now this difference is very important. Difference between thermoplastic and thermo. It is very important. So thermoplastic means uh, it deep thermoplastic means it has some elasticity but depends on type. Thermoset there is no elasticity. Thermoplastic it's softened when heated so it can be reshaped, but thermoset it cannot be reshaped, it cannot be remolded. It has weak intermolecular force, it has strong intermolecular force. Thermoset in thermoplastic is soluble in organic solvent, but thermoset is not soluble in organic solvent. In thermoplastic, they are flexible, not rigid, but thermoset, they are not flexible, rigid. So it can be easily broken. It can. So thermoplastic, it's soften when heated, but thermoplastic, this polymer, it's soften when heated. But thermoset, it can irreversible it can go some irreversible change, it can go some irreversible change and become much more solidified when heated. Okay, next is the introduction of stereochemistry of polymer. We'll discuss this part in the next video. Okay, so today what we have discussed is uh, what is polymer, that polymer molecules, what is polymer molecules means there will be repeating monomer unit which are linked together by covalent bond. Then we discuss different type of nomenclature of polymer, source based nomenclature, structure based nomenclature. Then we discuss different types of polymer, classification of polymer based on source, synthetic, semi-synthetic, natural. We discuss different type of polymer based on their structure, linear polymer, branch polymer, cyclic polymer, cross-link or network polymer. We discuss different type of polymer based on intermolecular force. For example, thermoplastic polymer, elastic polymer, fiber and thermoset. We discussed also difference between thermoplastic and thermoset. where most important part is thermoset polymer are very strong intermolecular force. They cannot be reshaped by on heating, and thermoplastic less intermolecular force can be reshaped upon heating. Okay, so next video we'll discuss this part. Okay, so I'll stop this video here. Next video I'll start from this introduction to stereochemistry of polymer. Okay, please wait few minutes. Please wait for the next video. I'll discuss this one in the next video.